Okay, so lesson 18 is solving quadratic equations using the quadratic formula. Okay, so that's probably one of the most important things you learn in grade 10 was how to use the quadratic formula to solve a quadratic equation. It's something you need to know for math, obviously, physics, chemistry, it's all over the place to be able to solve a quadratic equation. And the quadratic formula is kind of the go-to. Okay, that's the, if you're only going to know one method, that's the method everybody knows. Okay. And then, so that was grade 10, we already learned how to do that, but we're adding on the step where we express the roots exactly in simplified radical form when necessary. Okay. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Can be used to solve all quadratic equations, and that comes from them being in this format. Okay, so if you see a quadratic equation, you want to put it in this format. A will be the number in front of x squared. And you can see that it's in the formula here and here. I guess I should make that smaller. It's in the formula here and here. And then B, the number in front of x, including the sign. Okay, so if it's positive 5 in front of the x, it would be positive 5. If it's negative 5 in front of the x, it would be negative 5. It's here, the negative sign in front of it, and in here, okay? And then C, including the sign, is only one place in the quadratic formula. But all three of those numbers are in the quadratic formula, okay? And it can be used to solve all quadratic equations. So example, find the exact roots of each quadratic equation. Answers must be in simplified radical form where appropriate. So the first thing you're going to do is make sure everything's on one side and it's in this format equals 0 so that you can list what A, B, and C are. Okay? So A is the number in front of x squared, so it's 2. B is the number in front of x, so it's negative 10. And C is the y-intercept, so 5. The plain number, okay? Then you copy the quadratic formula out, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I always write the formula down first before I sub in because it helps me remember it. And as I said, a lot of you will be taking either physics or chemistry, math again next year. It's something you just want to know off by heart. Okay, the more times you write it down, the more you'll make a memory of it. So first step, write down the formula. Second step, substitute into the formula. So negative, I'm substituting in b as negative 10. So when you substitute, use brackets. So that's what that would look like. Plus or minus the square root of negative 10 squared minus 4 times 2 times 5. Notice how I'm using brackets and then substituting. All over 2 times 2. And then I always double check and make sure that my b's are negative 10s, my a's are 2's in this case, and my c is a 5. And it's very easy to accidentally put the wrong number in the wrong spot. Okay? And that throws your fully answer off. Okay, next step. So what does it mean when I have a negative, then a bracket, and then a negative 10? Good. So that means there's like a negative 1 there that's multiplying. So negative 1 times negative 10 is positive 10. So I've got x equals positive 10 plus or minus the square root of. Now in this next step, you should be able to get the number under the square root sign all at once. Okay, so you want to type into your calculator. Now, when you square a negative number, what do you get? All the time, right? 100% of the time? Negative 10 times negative 10 is positive 100. So I don't even type the negative in my calculator, I just go straight to 10 squared, because I know negative 10 all squared and 10 squared are exactly the same thing. So when I'm typing that in, I'm going to type 10 squared minus 4 times 2 times 5 equals, and it gives me 60. Make sure you can get 60. If you can't, let me help you with your calculator. Okay, everyone make sure you can get 60 for the number under the square root sign. So you're doing 10 squared minus 4 times 2 times 5. And then that's all over 4. Okay. So in grade 10, my class would then break off into two solutions, x equals 10 plus root 60 over 4, and x equals 10 minus root 60 over 4, and then I asked them to go to decimals after that, show me the difference between exact and approximate. But grade 11, we're going to simplify this as much as possible and just leave our roots exact. Okay? So the next step is to look and see whether root of 60 can be simplified. Is there a perfect square that goes evenly into 60? Yes, 4, and 4 is the biggest. So your next step down is going to look like this. So the root of 4 times 15 over 4. And then my next line down is going to be, I'm going to change root of 60 to 2 root 15. And I want you to look at this as the numerator has two terms. It has 10 and it has 2 root 15. Those are the two terms in the numerator. Okay? And the denominator just has a 4. If the 10, the 4, and the 2 have a common factor, then you want a common factor in the numerator to reduce. Okay? So do 10, 2, and 4 have a common factor? In other words, are they all divisible by the same number? Everyone agree they're all divisible by 2? So that means in the numerator, I want to common factor out 2 in order to reduce it. So if I common factor out 2, I would do 10 divided by 2, which gives me 5, plus or minus. So now this part's a little trickier, but what do you think 2 root 15 divided by 2 would be? So I'm doing 2 root 15 divided by the 2 that I'm factoring out. Yeah, just root 15, because the 2's divide out to give you what? 2 divided by 2 is 1, so we're just left with root 15 here. All over 4. So now I can reduce. 2/4 is the same as 1/2. Do you agree? So I can reduce 2 divided by 2 is 1, 4 divided by 2 is 2. Okay? 1 times 5 plus or minus root 15 is just 5 plus or minus root 15 over 2. Okay? That's probably the most common way to write the answer. You'll see in the back of the textbook. So the roots are 5 plus or minus root 15 over 2. Also, some textbooks write it like this. So they've got the a non-radical part separate from the radical part. So they both answers mean exactly the same thing. I don't care which way you want to write it. I'd say most textbooks nowadays will go to that, but there's still some that do that. Because they want the non-radical part without the square root separate from the part that does have the square roots. Okay? So those are two exact answers reduced as simple as possible. Okay? So those are our extra steps. So based on grade 10, you would have got to here. Okay? Look at all the steps we did to get to our answer in grade 11, which is simplest form, reduced radical form. Okay, so same idea for the next one. It's in a different order, so be careful when you're deciding what A, B, and C are. Did you guys get 3 for A? And 77 for B and 50 for C? Okay, no biggest tricks, good. Then write the formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Then we have our substituting step, where we put all the numbers in. So negative 77 plus or minus the square root of 77 squared minus 4 times 3 times 50 all over 2 times 3. So negative 1 times 77 is just negative 77 plus or minus, and now you want to get that number under the square root sign. So it's going to be 77 squared minus 4 times 3 times 50, 5,329. All over 6. Make sure you can get the 5,329 under your calculator. Under your square root sign, sorry, off from your calculator. So checking to see whether this breaks down. That's a huge number. So often when it's a huge number like that, it is a perfect square. So the first thing I would try is see if I can take the square root of 5,329. And I can. The square root of it is exactly 73. Everyone see that on your calculator? So my next line down then is going to be that x equals negative 77 plus or minus 73 over 6. Okay, so I have no need to reduce a radical. There isn't a radical. But I wouldn't leave my answer like that because I can actually add 73 to negative 77 and divide by 6. And I can actually subtract them and divide by 6 because they're just numbers, integers. So you can keep going, in other words, these questions until you get either an integer or a fraction in lowest terms. So negative 77 plus 73 is negative 4 over 6. Negative 150 over 6. This reduces, I could divide top and bottom by 2 to reduce it to lowest terms and get negative 2/3. So there's an exact solution. And here, negative 150 divided by 6 is exactly negative 25. So there's my other exact solution. So in this case, my exact solutions are rational numbers. Negative 2/3 is rational, negative 25 is rational. Over here, because they contain square root of 15, which is irrational, our answers are irrational. Okay? Irrational again, I always think of pi when I think of irrational. Numbers that go on and on forever, never repeat, never stop. Okay? They've got that radical symbol in them. And then these roots happen to be rational. So they have an order to them. Okay? Negative 25 is just an integer. Negative 2/3 is a repeating decimal, which is considered rational as well. Okay. All right, next. X squared plus 4x equals 41. So first thing I would do is subtract the 41 over so that I've got it in this format, ax squared plus bx plus c equals 0. And then once you've got it to here, okay, so my A would be 1, B 4, and C negative 41. Underneath the spirit sign. Okay. So now I'm checking to see whether there's a perfect square that divides evenly into 180. So 9 goes in. I want to see if a higher one goes in. 36 goes in. So 36 is the biggest one. So I'm going to change this here to 36 times 5. Then my next line down, let's going to change this to 6 root 5 over 2. So now is where I look at my 3 numbers and decide whether they have a factor in common. Yeah, I'll have 2 in common, so I'm going to factor out 2 in the numerator, because it's going to get to divide out with the 2 in the denominator. Okay? So then I have to do negative 4 divided by 2 is negative 2, plus or minus 6 root 5 divided by 2 is 3 root 5. All over 2. So now, 2 divided by 2 is 1. These just cancel out, give me 1. Okay, 2 divided by 2 is 1. So my final answer in simplest form would be x equals -2 plus or minus 3 root 5. And then that's really two solutions, -2 plus 3 root 5 and -2 minus 3 root 5. Okay? All right. Next one. First of all, you have to get all the terms to one side so that you can figure out what A, B, and C are. So I would subtract 5x on both sides and subtract 1 on both sides. And then I would get A to be 4, B to be 12, and C to be 3. Okay? Then I would write the quadratic formula out. And then substitute in. I've got everything in the right spot. Yep. Did you get 96 under the square root sign? 96. So then you have to find the biggest perfect square that goes into 96. And it should turn out to be 16. So then I can rewrite the square root of 96 as 4 root 6. And then I look at these three and decide what the biggest common factor that goes into all three is. 4. So I'm going to factor 4 out of the top. So negative 12 divided by 4 is negative 3, plus or minus 4 root 6 divided by 4 is just root 6, all over 8. And then I can reduce 4/8 to 1/2. Okay? So I end up getting x equals negative 3 plus or minus the square root of 6 all over 2 as my two exact solutions in simplest form. So one of them would be negative 3 plus root 6 all over 2, and the other one would be negative 3 minus root 6 all over 2. Okay, all quadratic equations can be solved using the quadratic formula. The method of completing the square should be used when it's relatively easy to change from standard to vertex form. Okay, so quadratic formulas your go-to, like if you like it, you could use it every time. Okay, but course expectations are you also know how to solve by completing the square. So I recommend just do that when it's easy to do that. Okay. And then tomorrow when we do factored math, just for factorable quadratics. Okay, not every quadratic can be factored. All right, so use two different methods to show that the roots of that quadratic equation are x equals 3 plus or minus root 7. So you have one side to show that you get those roots using the quadratic formula, and the other side to show you get them using completing the square. I'm going to pause. So for me, I would say A is 1, B is negative 6, and C is 2. Okay, so using the quadratic formula, I was able to get the 3 plus or minus root 7. Everybody good with the quadratic formula way? The hardest part was probably when you had to factor the 2 out of the top. Okay. And then we also want to do it this morning's way, where we complete the square. So that means we're first going to complete the square. So we're going to take half of 6, which is 3, square it. So add 9, subtract 9, but we still have the plus 2 equals 0. Okay? And then the first 3 terms form the perfect square trinomial, which factors to give us x minus 3 all squared. And then negative 9 plus 2 is negative 7. It's looking good. Add 7 to both sides. square root both sides, plus or minus on the right side here. Check to see whether 7 can be reduced. The radical of 7 can be reduced. No, it can't be, so I just leave it as plus or minus square root of 7. And then add 3 to both sides to get x by itself. And you end up getting exactly the same thing. 3 plus or minus the square root of 7. So I got the answer in 2 different ways. Everybody good? See the 2 different methods side by side. Turns out in this case, completing the square method took less steps than the quadratic formula. Okay. All right, if a ball were thrown on Mars, its height h at t above the surface, t seconds after being thrown is given by the function h at t equals negative 1.9 t squared plus 18t plus 1. How long after being thrown will the ball hit the surface? I'm always going to make a picture for these ones. This is where y is, so it's h at t. X is, so this is time. This is seconds, it says. All right, and we know this is our y-intercept, so we know we start, I guess, 1, whatever, above the ground is where the ball is released. And because a is negative, we know that it's an upside-down parabola. Okay, we know it's a parabola because of the squared. Okay, we know it's upside down because of the negative. And we want to know how long after it's thrown will it hit the surface. So this is where it hits the surface. And that's where its height above the surface is equal to 0. Right? Its height would be 0 when it hits the surface. Okay? So we can start off with our equation, but we want to replace height with 0 because we want to know how long it takes, the time it takes to hit the surface after it's thrown, after being released. So even though it's not x and it's t, can I use the quadratic formula? Yep, and do I have to rearrange anything to use it, or can I just say what a, b, and c are right now? I can say what they are right now. Okay, if you prefer to have it on the left, you can just switch the sides. And a is negative 1.9. And this is what's so great about the quadratic formulas. Numbers in like chemistry and physics are known as nice, perfect numbers, right? So you have a way that you can always find the roots or solutions, even if you've got decimals, so like 3 places or something, or scientific notation even. Okay, you can always use the quadratic formula. All right, so my first step is to write the quadratic formula down always for me. But I'm really careful when my variable is not x, in this case it's t, on my second line down, instead of writing x equals, it's kind of like stuffing in my a's, b's, and c's. I'm going to change x to t, because what I'm really solving for is time, not x. Okay? So time is my variable. And then I'm going to put 18 in for b. Negative 1.9 in for A, 1 in for C, so that's just my substitution step. And then check back and make sure you've got the B's in the right spot, the A's in the right spot, and the C in the right spot. Okay? Then you want to get the number under the square root sign, so that's going to be 18 squared minus 4 times negative 1.9 times 1 is 331.6 over negative 3.8. Now I'm not worried about reducing that radical because it's a word problem, but I am interested in if it's a perfect square. So I'm going to see if I can take the square root of 331.6. No, it's a decimal, so I'm just going to leave it for my calculator to deal with. Okay? But I tried it. I tried to see if that was a nice decimal, but it's not. Okay? So now I'm going to break into my two answers. So negative 18 plus the square root of 331.6 over negative 3.8. And t equals negative 18 minus the square root of 331.6 over negative 3.8. And now I'm just going to calculate these, making sure I can get the correct answers on my calculator. So the biggest thing is press equals after you do the top before you divide. That's the biggest thing to remember when you're typing it in your calculator. So once you've got it to the top, press equals and then do divide by negative 3.8. So negative 18 plus the square root of 331.6 equals divided by negative 3.8 equals, and I got negative 0.055. Now this is what's considered inadmissible because a negative time is not, for a word problem, a solution that makes sense. Okay? So that's a solution. It makes the equation work, but it's inadmissible because we can't have negative time within the context of this problem. Okay? And then here, hopefully we get a positive answer. Press equals, divide by negative 3.8, approximately 9.5 seconds. Okay, that one makes sense. So therefore, it takes 9.5 seconds for the ball, is it, to hit the surface of Mars. Anyone need help getting those numbers on your calculator? Everyone try to get them. Make sure you try to get them. If you can't get them, I'll help you with your calculator. Okay, is that it? Okay, let's go quick.